This video is for Lesson 3-2, Conditional Statements. Learning goals are to be able to identify the hypothesis and conclusion of a conditional statement and be able to give counterexamples that show that some conditional statements are false. Rules of logical reasoning involve using a set of given statements along with a valid argument to reach a conclusion. Statements to be proved are often written in if-then form. An if-then statement is called a conditional statement. In such statements, the if clause is called the hypothesis, and the then clause is called the conclusion. Here's an example. Here's a conditional statement. I know that it's a conditional statement because it has the word if and it has the word then. The part of the statement that's associated with the word if, so all of this part up to the comma, is called the hypothesis. Okay, the part of the sentence associated with the word then is called the conclusion. So this if-then statement is a sentence. It's a particular kind of sentence called a conditional sentence, a conditional statement. Here are some to try. Use the conditional statement. If x plus 7 is equal to 10, then x equals 3. First, can you identify the hypothesis? That's the part of the sentence associated with the word if all the way up to the word where the comma is. So x plus 7 equals 10 is our hypothesis. What's the conclusion? That's the part of the sentence associated with the word then all the way up to the period. So x is equal to 3. What we're saying is if x plus 7 is 10, then we can conclude that x equals 3. But that's only legitimate if we have justification. So question C, what is the property of equality that justifies that conclusion? That's called the subtraction property of equality. Conditional statements may not always be written in if-then form, but then we can restate them so that they are in if-then form. So question 1, restate each conditional statement in if-then form. Question A, I'll go if you go. We can rewrite this with the words if and then as long as we get the proper part of it as the hypothesis and the proper part as the conclusion. We don't want to accidentally reverse the logic of what this sentence is saying. This is saying if you go, then I'll go. Question B, this one's a little bit harder. There is smoke only if there is fire. This has this phrase here, only if there is fire. Because of the word only, that part of it is actually equivalent to the word then. I know that's kind of confusing, that the phrase only if means something different than just the word if. So the proper way to rewrite this is, if there is smoke, then there is fire. Question C, x equals 4 implies that x squared is equal to 16. This word implies is a synonym for the word then. So a way to write this is if x equals 4, then x squared equals 16. An if-then statement is false if an example can be found for which the hypothesis is true and the conclusion is false. This type of example is called a counterexample. Number 2, this is a false conditional statement. If two numbers are odd, then their sum is odd. Question A, what is the hypothesis of this sentence? Again, the hypothesis is the part of the sentence associated with the word if. So two numbers are odd. What's the conclusion? That's the part of the sentence with the word then. Their sum is odd. We want to show that this sentence is false, and we can do that by giving a counterexample. Can we think of two numbers that are odd, but their sum is not odd? Let's try. Here are two numbers that are odd, 3 and 5. If we find their sum, that's an even number. This one example is sufficient to show that that sentence is false. If something is not true all the time, then it has to be a false sentence. Here are some check your understanding questions, so I'll pause the video. So in this video, we discussed a particular type of sentence that's often used in math class called a conditional statement. A conditional statement has a hypothesis and it has a conclusion. It often uses the word if and then. Some conditional statements are actually false, and we can show that they're false if we're able to find any counterexample.